Day 152 of doing a LeetCode problem every day until I get a job. All right, y'all, welcome back. Welcome back to another day, another LeetCode problem. Today we're about to do our first hash map or easy hash table problem. We're about to start a month. We're going to do a month or so of easy hash tables before we get into the LeetCode top interview 150 questions. We want to make sure that we build our foundation and strengthen our fundamentals before we move on to the tougher questions. But yeah, today is the first day of that. We're doing the easy hash table question. So yeah, get excited about that. And before we get started today, y'all, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could do our part as Swift community members to help push this content out to a broader audience, y'all. It's up to us to help the community grow, and in order to do that, we have to share this Swift content with as many people as we can find that will actually watch it, y'all. So y'all support is appreciated for that. Now, with all that being said, let's get into the question. And today we have question number 141, linked list cycle. The difficulty level is easy. So if you've been on this channel before, you know we're going to keep the solution as simple and easy to understand as well, because we're all here trying to learn something. And if you don't understand the solution, then you probably didn't learn anything, and that is not what we want. So yeah, we're going to make the solution available, or not available, but we're going to make the solution easy so anybody can understand it no matter where you are on your LeetCode journey. So let's get into it. The question says, given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that the tail's next pointer is connected to. Note that POS is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. So let's break that down, see what they mean, because I understand how it can get a little confusing, right? So the first thing that we are going to do is we are going to see what the examples say. So example, we have the input head. It's an array of integers, 3, 2, 0, and -4. POS equals 1. The output is true. The explanation says there is a cycle in the linked list where the tail connects to the first list node, 0 index. Okay, so let's get into it, because even then it's still confusing, right? So this is the linked list right here. Boom. These nodes right here, we're looking at the picture. These are that's the representation of it, but this is what we're looking at. So POS equals 1. So POS right here, boom, let's see what POS says. It is said it is used to denote the index of the node that the tail's next pointer is connected to. Note that POS is not passed as a parameter. So we see in the function POS over here, it's not passed as a parameter over here. However, it's still important in the question. Why, you ask? Because POS lets us know that after -4, we're going back to index 1, right? That's POS says 1. POS is used to denote the index of the node that tail's next pointer is connected to, right? So POS lets us know that the tail, in this case -4, is connected to index 1, which is 2, which lets us know there's a cycle because it never ends. Now say there was no POS, right? Let's say POS didn't exist. Then -4 would be the tail, that would be the end, and we will return false because there is no cycle. But since this POS says 1, that lets us know that there's a cycle, because after -4, which is the tail, we're going to repeat and we're going to go back to index 1. Then we're going to go from index 1 to index 2 to index 2 to index 3, which is the tail, and we're going to do it again. Boom, we're back at index 1, then we go 2, 0, -4, boom, then we do it again, right? So that's the cycle, because every time we get to -4, POS lets us know that we have to return back to index 1, which in this case is 2. So that's a cycle because it never ends. Every time we get here, we got to go back, get here, go back. Now, say there was no POS, then we would know it ends at -4 and the output is true. Where I think they don't really show an example. They kind of show an example. We'll get to it down here where we're -1 because there is no -1 index, so it returns false. But let's stick with example 1 right now. So that's how the cycle works. At -4, we go back at the tail, which is this case is -4. We go back to index 1, right? So that's why the output is true, because there's a cycle. There's a cycle in linked list where the tail connects to the first node and the 0 index, right? That first node comes from this POS1. So that's how we know. So that's why the output is true, right? So then we could come down here and we could say, or we could, let's look at this too. It says head, this time with input head, an array of integers 1, 2, POS equals 0. The output is true because there's a cycle in the linked list where the tail connects to the 0th node. So we know once we get to the tail, we're going back to index 0. This 0 stands for index 0, right? So go to the tail, we're back at index 0. We go to the tail, we're back at index 0. We go to the tail, we're back at index 0. That's a never-ending cycle. That's why the output is true. Let's look at example 3 where the output is false so it can make some more sense. Input head equals equals an array 1, POS equals -1. Now there is no -1 in a 0 index integer array, right? So the output is false because there is no cycle right here. There's no cycle in the linked list. You can't take the tail and go to -1. It doesn't work like that. There is no -1. So we're just going to return false. So let's get into the part that all keeps us going. Right now that we understand the question, let's get into the fun part, the part that we all like and love, the actual code. And the first thing we are going to do is we're going to declare a variable called slow, and we're going to set that equal to head, right? And that is going to represent the first number in the list, right? Or the first integer in the list. Then, or the head, you know what I'm saying? Then we're going to declare a variable called fast, and that is going to be equal to head question mark, because it's optional, because the list node is optional, dot next. And what that is going to do, so fast, in this case, head would be 3, head dot next would be 2, because the next after head is 2, right? So if this is head, head dot next would be this one right here, which is 2, right? Has a value of 2. Then we're going to come down here and we are going to say while fast, or we're going to say while, we're going to open up the parentheses, we're going to say fast does not equal nil, and we're going to say, and, excuse me, 2 and signs, slow does not equal nil. Then what we are going to do, we're going to come out here, we're going to open up our brackets, and we're going to say guard slow does not equal fast with exclamation point equal sign, 2 equal signs, or 1 exclamation point and 2 equal signs, because that just makes it a little bit more explicit. Then we're going to say fast. Then we're going to say else return true. Boom. Then, so that lets us know that if slow does not equal fast, we're going to return true, because that means there's a cycle. Then we're going to come down here and we are going to say slow equals, slow question mark dot next. And we're going to come down here and we're going to say fast question mark equals, moving too fast, y'all. Fast equals fast question mark dot next. So we're basically just incrementing the slow and the fast, right? Then we're going to come down here. All else fails, we're going to say return false. And that should be all she wrote, y'all. So let's see it. Let's see it. Make sure it runs. Ooh, okay. Let's see what happened. What we oh, this should be an exclamation. A question mark here as well, y'all. Sorry. Let's see, and it's accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. Ooh, look at that, y'all. 21 milliseconds beats 97.66% of users with Swift. Now that's what I call some good timing right there, y'all. Some would I ain't gonna, nah, it ain't perfect timing, but it's good timing. You know what I'm saying? We'll make it work, y'all. So I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. Peace.